Okay, so this session is going to be on the skeletal system. So the skeletal system is made up of our skeleton and our bones, 206 bones in total. When we're talking about the bones, we need to look at different types of bone tissue. So there are two different types of bone tissue. We have compact and cancellous. C-A-N-C-E-L-L-O-U-S. Compact bone is the one that we're going to look at first, is a harder, denser, stronger layer of bone or type of bone tissue, and this sits on the outer surface of the bones. So the outer area is made up of compact bone tissue, much harder, denser, stronger, and tougher. On the inside of that, we have our cancellous or canculous bone tissue. And this is much more of a spongy layer. And if you visualize your bone tissue a bit like a sponge and all the tiny little holes you have, with your canculous or cancellous bone tissue, those little holes are called Haversian Canals. And they're much widely spaced apart. So the bone tissue is much, much more spongy. It gives a little bit under pressure. Whereas your compact bone tissue, it speaks for itself. Those Haversian canals are much more tightly packed. And so that makes the bone much denser and stronger, harder. Our bones along the outer surface are then covered in something called periosteum. P-E-R-I-O-S-T-E-U-M. This is a type of connective tissue, and it covers the edges of bones and supplies them with blood, which enables the bones to reproduce, repair, renew, grow. So on the outer layer, we've got that periosteum, a very thin covering. We then come into our compact bone tissue, which is much more dense, tough, solid. And then on the inner portion of that, we have our canculous or cancellous bone tissue. So within our canculous bone tissue, we have got red and yellow bone marrow. So our canculous bone tissue is filled with bone marrow. Red bone marrow is responsible for producing blood cells. And yellow bone marrow stores fat. So two types of bone marrow, one that produces blood cells. So our red bone marrow produces blood cells. Yellow bone marrow stores fat. And that would be the last place that your body would take its fat stores from. So we store fat in that subcutaneous layer of our skin, that hypodermis. We store fat around our organs, that's our visceral fat. And then we also have a store of fat in our yellow bone marrow. And in times of famine, that would be the last place that the body would take its fat stores from. So that is the structure of the bones that we're looking at. And then we need to think about, we've got all of these 206 bones, but how are they joined together? And that's the exact word we need to use. So bones meet together at a joint. So where two bones come together, it forms a joint. And there are three types of joint in the body. Number one, we have a fixed or fibrous joint. You could even say fused. So these are joints that are fixed or fused. There is no movement at these joints, zero movement. An example of bones that form a joint that is fused, fixed or fibrous is the bones of your skull. So the only bone that isn't fused, fixed or fibrous is your bottom jaw. That's the only one that can move. Your frontal bone to your parietal bones, your occipital, zygomatic, are all fused together. The only movable bone is your lower jaw, which is called the mandible. We will come back to the names in a moment. Just as a sideline bit of information, the parietal bones are the two top of the skull bones here. When we are born, they are not fused. So up until about the age of 2, those two bones aren't fused, and there's like a little soft spot on babies' heads, and that pulsates, or you can see the pulse there. That gives the brain room to grow, but by the age of 2, those bones are fused. So fixed, fibrous or fused joints, zero movement. Our next type of joint is a cartilaginous joint. C-A-R-T-I-L-A-G-I-N-O-U-S, cartilaginous joint. These joints have limited movement. An example of this would be your vertebrae. So your spine, you probably feel like you can move it quite a lot, but actually the movement that you're doing starts to engage your pelvis, your hips. So the only movement you can really do with your vertebrae is a very small sort of tuck, but it's not long before your shoulders and your hips become involved. So the movement of the spine is a very, very small, limited movement. So the bones of the vertebrae would be known as cartilaginous joints, limited movement. And lastly, we have synovial joints, S-Y-N-O-V-I-A-L. These are freely movable. So these are joints like your shoulder, your elbow, your wrist, your fingers, hips, knees, ankles, toes. They do different movements. So if you look in some of your anatomy and physiology books, or if you look online, you will see that there are different names for the joints that can do different movements. So for example, your elbow and your knee can only flex and extend. That's called a hinge joint. There are some, like your wrist can flex and extend, but it can also rotate. That's got a name as well. So depending on the types of movements those joints can do, they have got specific names. Don't particularly worry about those, but if you're interested, you can look. Your shoulder and your hip are called ball and socket joints. They can do every single movement: flex, extend, abduct, adduct, rotate, etc. So your synovial joints are freely movable, but that doesn't mean they can do absolutely every movement other than your shoulders and your hips. They can. Ball and socket can do every movement. So let's have a look at a diagram then that I've drawn, which you can copy or just screenshot even if you want to, of a joint diagram. So it's a very basic diagram. I'm going to talk through what you're seeing. So two bones together are meeting at a synovial joint. At the ends of the bone, the green section, we have got a covering over the edge of each bone, which is cartilage. This covering of cartilage is going to protect the edges or the ends of the bone and avoid the bone rubbing together. So the green area is cartilage, covering the ends of each bone. The black area that I've shaded is an area where we've got something called synovial fluid. This fluid allows the ease of movement between the bones at a joint. And then lastly, so the bones just don't all collapse, we've got two structures here of connective tissue. And this is a structure that holds bone to bone, and it's called a ligament. So ligaments hold bone to bone. So think about how we can use that in our treatments. So we know, we've heard about ligaments, we've probably heard about ligament damage. Well, now you understand what a ligament does. So all over the body, we've got ligaments that are holding bone to bone. So think about how your massage treatments could affect perhaps damage or issues, or just generally the health of those ligaments. We know we've got two bones, and at the covering or at the edge of those bones, we've got that cartilage. This stops the bones grinding against each other. But we also probably have heard that as we age, or if we have issues with joints, our cartilage can start to wear away. And then when that bone on bone action happens, because that cartilage is worn away, that's where we get a lot of pain. But also we've got that synovial fluid, which is going to protect that joint. So that fluid bathes the joint and enables the joint to move really freely. Think about the oil in your car. It allows the structures in your car to move well. So think of that synovial fluid as the oil for your joint. Now again, as we age, that fluid is probably going to be less fluid-like. So you hear about people older getting up in the morning and they feel that their knees are all creaky and they need to move about a bit to get everything flowing and moving. Well, think about that fluid. So think that that fluid could become thicker and almost a bit sticky-like, and imagine moving those bones through really thick, sticky honey. But then as we warm that honey and it becomes looser and more fluid-like, those movements are going to be much easier. Now think about your massage movements, massaging the knee, warming, bringing the blood circulation to the area, warming that fluid, which is going to make those movements much easier. Makes sense, really, doesn't it? So structure of a joint, you've got your two bones covered in your cartilage, which acts as a bit of a buffer to the bones. Bathed around the joint is your synovial fluid, aiding the movement of that joint. And then attaching your two bones together, you've got your ligaments. The only other thing you can think about adding, or you can't really draw it particularly on there, but when we come to do the muscular system in the next lesson, that's when we'll start to talk about tendons. Tendons attach muscle to bone. So that's something just to write down, those two definitions: ligaments, bone to bone; tendons, muscle to bone. It's really easy to get those mixed up. So if you start to get that in your minds now, you have it clear. So then let's have a look at the function of our, or functions of our skeletal system. So we have 6 functions. The first one is shape. Our skeleton, or our skeletal system, provides our own unique height and length of limbs. So our skeletal system offers us our shape, nice and easy. Second is support. So our skeletal system, each part of it will support the body, supports it through posture, but also if you think about like the pelvic girdle, that supports the weight of the whole of the upper body. So each structure, it's a bit like building blocks. Without the other structure, you haven't got the support to build on top of it. So generally our skeletal system is support. The next one, which is super obvious, is protection. So our skeletal system, particularly in our thorax, is a protective outer area for our internal organs. So our heart and our lungs, some of our digestive organs are protected by our skeletal system. Our brain is protected by our skull. Our next function is storage. So first of all, our bones are an area where calcium and phosphorus from our diet is stored. So calcium and phosphorus stored in the bones. But also, right at the start, we talked about another form of storage. So remember our yellow bone marrow, that stores fat. So 2 areas of storage: calcium and phosphorus, and fat in our yellow bone marrow. And remember that calcium and phosphorus being stored, there was something that we talked about in the integumentary system that was vital for that, which is vitamin D. So the skin is our main source of vitamin D in the body, and vitamin D was crucial for our ability to store calcium and phosphorus. So without vitamin D, we are not able to store those 2 minerals. The bones are pretty clever. Our next function is production. So again, remember back to the beginning, we talked about that red bone marrow producing blood cells. So a function of our skeletal system is production. Our red bone marrow produces new blood cells. So that is why when a person has a cancer of the blood, they need a bone marrow transplant, because the cancer is in the blood coming from that reproduction of cells. So they need to kill the cancer cells within the body, so with chemotherapy usually first, and then they need to treat the source of the problem. And because the blood cells are being produced by that red bone marrow, the issue, the dysfunction of why those cancer cells are being produced is in the bone marrow. So they need to stop the patient's bone marrow working, kill the cancer cells, and then replace the bone marrow with healthy marrow so that that bone marrow can start producing cells that are healthy. And the last function is movement. So we've talked about how two bones meet at a joint enables the body to move. Remember, they are joined with ligaments. Now, the skeletal system can't move on its own, so there is another vital system that needs to work alongside that, because the skeleton by itself cannot produce movement. But the next system we look at will be the muscular system. And the fact that the muscles, the skeletal muscles, are attached to our bones enables then the bones to move. But the fact the bones have got joints enables that movement to happen as well, because if there were no joints, no movement would be able to occur. And I've just talked then about skeletal muscles. If you think back to the lesson we did on cells and tissue, we talked about 3 types of muscular tissue. And one of those was skeletal muscular tissue, which was that voluntary. It's your bicep, your tricep, the movements that we do with our skeleton. So in a nutshell, other than looking at our diagrams and labeling them, that is the information that you need on the skeletal system. So I'm just going to very quickly recap. So 2 types of bone, compact and canculus. Compact bone is hard outer layer. It's strong, it's dense, and it's tough. We've then got canculus or cancellous bone tissue, which is the spongy inner layer. Covering the outer surface of bones, we have periosteum, which is a connective tissue that supplies the bone with a blood supply. That blood supply enables the bone to heal, to grow, to repair. So, interesting fact, when we are children, we have far more canculus bone tissue than compact bone tissue. If you think when we're toddlers, we fall over a lot. And so we're learning to do movements and learning skills that actually require us to be a bit bouncy. Because if we broke a bone every time we fell over as a toddler, it would be a bit of an issue. As we age, we get more and more compact bone tissue, which is why if a 90-year-old fell over the same amount of times as a toddler did, they would have far more broken bones, because our bone gets thicker and denser and more compact as we age. So within that spongy bone tissue, that canculus or cancellous bone tissue, we have 2 types of bone marrow. Red bone marrow, which produces new blood cells, and yellow bone marrow, which stores fat. When we get 2 bones that come together, they meet at what we call a joint. We have 3 types of joint. The first one is a fixed, fibrous or fused joint. These joints have 0 movement. Example is bones of the skull, other than your mandible, your lower jaw. Next, we have cartilaginous joints. These joints have limited movement. Imagine the bones of the spine, the vertebrae, they very much just have a little collapsing movement. And lastly, we have synovial joints, which are freely movable, and those relate to our shoulders, elbows, wrist, fingers, hips, knees, ankles, feet, toes. They do a wide range of movements, with the shoulder and the hip being able to do every single movement. So they can flex, extend, they can rotate. So then that leads us to looking at that diagram of a synovial joint. 2 bones meeting, covered in that protective cartilage, that connective tissue that stops the bones grinding against each other. That joint is bathed in synovial fluid, again to add lubrication to those movements. And the bones, to stop them all falling to our feet, are attached with ligaments. There will then be muscle that is attached to these bones to enable them to move, and those muscles are attached with tendons. So 6 functions of the skeletal system. Skeletal system provides our unique shape, so it depicts the length of our limbs and our height. Our skeletal system is supportive, so it supports the weight of our upper body onto the pelvis. Massive form of protection, so our brain and our internal organs are supported and protected by the skeleton. Our bones are able to store the minerals, calcium and phosphorus, but also the yellow bone marrow stores fat. Our skeletal system, a function is production, so our red bone marrow produces new blood cells. And lastly, our skeletal system is able to move. So those ligaments joining bones at a joint enables movement of the body once we bring in the muscular system. Okay, so then we're going to look at labelling our little friend here. So we're going to look at naming the bones of the body. So they're each numbered. So if you haven't got your sheet printed out, then you can just list them. And then if you do print it out at some point, you can add them on. So I'm going to look at him so I know which one I'm talking about. So number 1 is pointing to the forehead. This bone is called the frontal bone. Frontal, F-R-O-N-T-A-L. Remember that bone is fused to our 2 scalp bones, which we'll come to later. Number 2 is pointing to the nasal cavity here, and these bones are the nasal bones. Nasal bones. There are a few different ones in there. You don't need to worry too much about the names of those at the moment. Number 3 is pointing to our cheekbone. This is the zygomatic. Z-Y-G-O-M-A-T-I-C. Zygomatic. Number 4 is pointing to our top lip. This is actually a fused bone. So it's 2 bones that are fused in the center, and this is the maxilla, M-A-X-I-L-L-A. And then our only movable bone of the skull is number 5, which is this bone here. This is called the mandible. M-A-N-D-I-B-L-E. So number 6, we've got the bone that sits along the top of the chest. This is the clavicle. And the 2 clavicle bones are joined in the center to the sternum. So number 7 is the sternum. Coming down from the clavicle, we have got number 8, which is the long bone of our upper arm. That is the humerus. H-U-M-E-R-U-S, humerus. Think about, remember that, because we call our elbow our funny bone. And so this arm is, this bone here is the humerus. I know. In our lower arm, we've got two bones, one that stretches to the little finger side and one that stretches to the thumb side. The one to the thumb side is the radius. So that is number 9. And then number 10, which is coming to the little finger side, is the ulna. U-L-N-A. Remember that, as ulna is like a little word, and that goes to the little finger side. So radius and ulna. And then that comes down to our wrist. We've got 8 bones in our wrist, and they are called the carpals. C-A-R-P-A-L-S. 8 carpals. That's number 11. Coming over to the other side of our friend, we've got number 12, which relates to the bones of the hand. So we've got 5 bones that stretch towards from the wrist to each finger. And those are called metacarpals. So M-E-T-A carpals. So 5 metacarpals. So in body massage, when you're massaging the palm of the hand, or when you're doing that in Indian head massage or aromatherapy or manicure, you are massaging those 5 metacarpal bones. And then we've got our finger bones. So in each thumb, we've got 2 bones, and in each finger, we've got 3. If you look, my finger can bend in 3 locations, 3 joints, but my thumb only in 2. So in each hand, we've got 14 phalanges. Remember that from Friends? So P-H-A-L-A-N-G-E-S, phalanges. And then we're just coming back up that side of our model to number 14, which are the ribs. I just want you to label something that you can't particularly see on that diagram. But at the back here, we've got our shoulder blades. Which is called the scapula. So joining to the back of the arm, we've got our scapula. S-C-A-P-U-L-A. That's our shoulder blades. So then we come down to 15, which is the pelvic girdle. And then extending down the lower part of the body, we've got the long bone of the upper leg called the femur, F-E-M-U-R. Number 16 is the femur. Number 17 is our kneecap. That's our patella. P-A-T-E-L-L-A, patella. And then like on the arm, we've got 2 long bones that form the lower leg. One that comes to the big toe, which is number 18, and one that goes to the little toe, which is 19. The tibia is number 18. T-I-B-I-A, it's the bigger bone, and just think tibia goes to the big toe, T-T. So number 18 is tibia, and number 19 is fibula, F-I-B-U-L-A. That goes to the little toe. Then we've got the bones of the ankle. These are very similar to the wrist bones, but there are only 7. So remember that the higher up the body, you had 1 more. So the carpals in the wrist, we've got 8. In the ankle, we have got tarsals, T-A-R-S-A-L-S, tarsal bones, and there are 7. So remember, the tarsals are near the toes. The carpals are higher up, so T and T. So 7 tarsal bones, which lead to our feet bones, a bit like on our hand. 5 long bones along the foot, and these are metatarsals. 5 of them in each foot. So that's 21. And then lastly, 22 is our toe bones, and they are exactly the same as our finger bones. So our big toe is able to bend in 2 places, and each of our little toes is able to bend in 3 places. So even our tiniest toe has got 3 little bones in it. And they are called phalanges as well. So 14 phalanges in each foot, 28 in both. So that is your little model there with all of the bones you need to learn, and just adding on your sort of hidden scapula at the back here. It's your shoulder blade. It's a flat bone sitting at the back there. So now when you're starting to massage your clients, you can be thinking about the bones that you're having a direct impact on when you're doing the treatments that you are, and the different joints that might be in those areas. Okay, so then let's look at one major area that we haven't labelled, which is the spine. So the spine is made up of vertebrae, bones that each stack on top of each other, and in between each of the bones there is a layer of cartilage. Remember, this has got very limited movement, just a little bit of a collapsing movement. And we split the spine into sections. So the first section has got 7 vertebrae, and this is called the cervical vertebrae, spelt like cervical, C-E-R-V-I-C-A-L. But so we know which end of the body we're talking about, we'll call it cervical. So 7 cervical vertebrae. Then the major portion of the spine here, so where the cervical vertebrae end, we've got 12 vertebrae. And this is the thoracic, T-H-O-R-A-C-I-C, thoracic. This makes up a huge portion of the back. So probably from just after the base of the neck, past bra strap level, sort of, oh, it's hard for me to show you, but it's a big portion. When we're together, I'll show you. From the base of the thoracic then, so 12 vertebrae, we have got 5 lumbar, L-U-M-B-A-R vertebrae. This is the lower curve of the back, the lumbar curve. L-U-M-B-A-R. There's 5 vertebrae here. We've then got an area of 5 bones here, but these are fused. There's no movement in this area here. This is the sacrum, S-A-C-R-U-M. So 5 fused bones in the sacral region or sacrum. And then at the very bottom, we've got 4 bones, again fused, and this is the coccyx. C-O-C-C-Y-X. So, cervical vertebrae, into thoracic, into lumbar, into sacrum, into coccyx. So when you're working your different treatments, you can be visualizing again how much of the spine you're working and where we hold tension. So an offshoot of this is to look at postural complaints. So issues that we have with the spine that cause posture faults. And there's 3 that we'll look at particularly in your classes. Okay, last 2, a little bit scary ones. We've got our forward-facing skull. So we've already labelled a couple of these on our full diagram. So number 1 is our frontal bone, the bone of the forehead. Number 2 shows the sides of these 2 bones here. Remember, these 2 bones are not fused when we're born, and after about the age of 2, they become fused. These are called parietal. P-A-R-I-E-T-A-L, parietal. We've got then number 3, which relates to the side of the skull. In here and in here. These are the temporal, T-E-M-P-O-R-A-L, temporal. Easy to remember because it's at the temple. Number 4, we have already labelled on our full skeleton. This is the zygomatic. Number 5, we've already labelled. This is the top lip. You can see now more clearly that this is 2 bones which are fused together, called the maxilla. So it in total is called the maxilla, but it is actually 2 bones. And then number 6 is a large bone here that's joined at a joint up here near the temples, which is the only movable bone of the skull, which is the mandible. So it enables us to chew. And then just so you can see a different section, we're doing the profile section. So we can see that number 1 is that frontal bone, bone of the forehead. Number 2 is one of the parietal bones. Number 3 is that temporal bone. Four is the cheekbone, the zygomatic. It labels the same actually. 5 is your maxilla. 6 is the mandible, and you can see where that bone is then movable in that joint in here. And then lastly, 7 is a new one. That is the occipital. O-C-C-I-P-I-T-A-L, occipital. And if you feel behind your head, come up your spine, and then you'll feel there's like a dip right at the top. So the bone that you're feeling either side of that dip is your occipital bone. And then that dip that you're feeling is called the occipital cavity. So those of you who have done facials, when we did the facial massage and we came round the shoulders and we pull into the neck, we hook our fingers into that occipital cavity and we stretch. Those of you doing or done Indian head massage, as you come to work on the neck, you will do some pressure points around the occipital ridge, which is that ridge you can feel, and into that occipital cavity. So it's the area where the spine joins the skull. So holds a lot of tension. It's where the weight of the head is being carried. So occipital bone, and then you've got that occipital cavity at the back of your head. So you've got those diagrams to look at and to revise from, and obviously label if you haven't done already. So that is the skeletal system complete.